others sit down. Guys? Hey, well, we continue now. So, admin and company, sit down.
I'm trying to wait for them to sit down.
Don't make me. Sit down. Close enough. Sit. Okay. Hey. Dude.
Bro,
Sit down. Come on. We're starting now. Guys, come on. So, now, what we have to do today, there is one extra lesson left in algebra to do, which I just uploaded a few minutes ago. This lesson is about distance and area. Okay. It wasn't on Moodle yesterday. It's up there now. Which one?
everybody had a hard time.
About what? Oh, the last one? Oh yeah, okay. Well, I think the math tutorial will be best for that. So if we need to make the math tutorial only about this, we could do that. Does this cause a lot of trouble for a lot of people? Okay, yeah. So we'll do some more examples tomorrow then of that. Yeah. Okay. Right, so as I was saying, what we're going to have a look at is distance and area. This is, guys, here. This is group 1 and 2. So everybody here is medicine?
Yes.
Yeah, because the science students are in group 3 and 4, isn't it? Yeah. So everybody here is medicine application, isn't that right?
Yeah.
Okay, so just some information which is important for you. This particular lesson is not actually on the IFY course, but the reason I'm doing it is because it is on some of the entrance tests which you may have to do depending on what your application is, okay? And even though this is not on the course, what you learn here, you can use it to help you with other questions. So there's some questions in the exam, and there's one way of doing them, but you can do it using what you learned today if you want. So I mean, it's not a total waste of time doing this. It will either help you with some of the IFY questions, or it will help you in your entrance test for medicine. So it's going to help you one way or another, but just so you know, technically this is not on the syllabus, okay? So I just thought you should know that when it comes to your revision. So for example, in the end of semester 1 exam, this topic won't be on the exam, okay? Huh? Did you just say, so I can skip it then? Did you? Were you not?
That's what. Calm down.
I'm going to pretend I didn't hear that, take some coffee, and then start. No need to repeat, thank you. No need to repeat. No need to repeat. It's all okay. Thank you. Do you need to talk to them, or? No, okay. Alright, so I'll start by giving you the formula for the distance between 2 points, okay? And this formula, in fact, is probably a formula that you've seen in high school before, how to get the distance between 2 points. We've already seen how to get the slope between 2 points. So now looking at the distance. Now there's no need to be talking. No talking, please. So the first point, don't leave it open, okay? No, just leave it the way it is. It's perfectly fine. Hang on, you speak English, don't you? Leave it the way it is. It's fine. It's fine. I don't know how you have so much energy after 2 hours of biology and 1 hour of chemistry. Right, okay. Now, the formula for the distance between these 2 points. So does anybody remember this formula from high school? The distance between the 2 points. Yeah, so what do I start with? There's a square root firstly. Not quite this, no? Yeah, x2 minus x1 squared plus y2 minus y1 squared. Okay. So this, I mean, it's a lesson that I said is not on the exam, but it's something that you already know. At least this part is anyways. So I think what we'll do is we'll just do a simple example of this. Okay. So a simple example would be find the distance between, we'll say 4, 6 and 9 minus 6. Okay, so once you write this down, I want you to try this one. It should not cause you any trouble. And by the way, if I swap the 1 and the 2, so if I said, for example, x1 minus x2 and y1 minus y2, will I get the same answer? Yeah. What about if I said x1 minus x2 and then y2 minus y1, will I get the same answer? I will get the same answer. I will. So it really doesn't matter which way around you use the x's. As long as you have two x's with a minus here and two y's with a minus, you'll get the right answer. The order's not important. Common mistakes the student make is mixing up the minus and the plus. So it's minus on the inside with the square and then plus between them. You got an answer? Yep. Okay. So let's calculate here. The distance will be square root. So 9 minus 4 squared plus minus 6 minus 6 squared. So this is 5. Yeah, this is 5, isn't it? Yeah, and then this is 144. So what's that? Root 169, which is 13. So that's okay. So it's just straightforward use of the formula for this. So it's actually a good question if you get it in the entrance test. Has anyone talked to you about the entrance test for some of the medical schools?
Yeah.
Yeah. So what they do is they give you 10 maths questions to do, and they're not too hard to do. You know, some of the questions might be like, what is the distance between these 2 points? The difficult part of the test is you have no formula book. So what they're really testing in that question is, do you remember this formula and can you use it correctly? You know. So if you do remember it and you can use it, then that question is very easy for you. And there'll be 10 questions in total. Sometimes there's 15 depending on the test. Okay. All right. So that's the first one. Do you have this? Yeah. Now the next one, maybe some people have seen it, but maybe not. So in the next one we have a point and the line, and we want the distance between the point and the line. And we want, what's this distance called actually? Yeah. Perpendicular distance. Perpendicular distance, yeah. So we have our point x1, y1, and we have our line, we'll write it as ax plus by plus c equals 0. Yeah? Okay. Does anybody know the formula for the distance between a point and a line? Does anyone know it? No, so this is a new formula, is it? Yeah. Okay, so the distance here divides, and on the bottom is a squared, go on, plus b squared. And on the top? Yeah? No, okay, close. ax1 plus by1 plus c. And there's this thing around it. Does anyone know the name of this? Absolute or modulus. It just means make it positive, yeah, because distance should be positive. So again, it's just a matter of using the formula. There's nothing special here. Here's one for you to try. We'll say the point is minus 8,5, and then the line is minus 3x minus 4y minus 2 equals 0, and I want the distance from here to the line. Okay, just take a minute or two to do this one. Do I have everybody now? 1, 2, 3, 5, 6, 7, 8, 9, 10. Baher's the only one missing, yes?
Been missing for a week.
Yes.
No.
We don't. No, we don't.
No.
No one knows. Yes.
Yeah.
Okay, do we have an answer here yet?
Not yet.
Not yet? So down below, we have 9 plus a squared plus b squared. Just to be clear, this is the a, this is the b, this is the c, this is the x1, this is the y1. So yeah, plus 16. Then we have a x1 plus b, sorry, a x1 plus b y1 plus c. So on the top we'll get, what's that, 20 minus 24 minus 20 minus 46, is it? On the top? Is that right, or is there a mistake? Say again? What's on the top? 2? On the top? Oh, that's a positive, sorry, thank you. 24 minus 20 minus 2 is 2. And then on the bottom is square root 25, which is 5. So the answer is 0.4. No, don't have to. 0.4 units, yeah.
Do you have the previous papers, like, does this school have the previous papers of the trick exam?
Yes. Well... we have some of the previous papers. They don't actually release all the papers, so we only have the ones that they released. So we have some of them, yes, but not all of them.
And you can help us prepare again.
And usually what happens is we use the past papers as preparation for the test. Okay, did you have this one written down? Yep, okay, so I want you to try this one. It's the same idea. I want the distance between the point and the line. But this time it's written a little differently. I don't think it will cause you much of a problem though. Minus 9 minus 2 is the point, and the line is y equals 2 over 5x plus 8 over 5. And I want the distance from here to here. I want this distance. Try this one for a minute now. Yes? Casio 991 is the best one. I can pretty much use any calculator in the exam, but the recommended one for the course and the exam is Casio 991. Yeah.
Are we allowed to use calculators in the trick exam? Because I know that
No, I don't know. They say no, but they often do let students use the calculators. But I've noticed that they designed the question so that it's possible to do without a calculator, the numbers that they use. So I think officially on their website they might say no, but often the invigilator allows the students to use it in the exam. So I would say probably yes, but prepare for the possibility that it might be a no, okay?
Does it ever happen that is no?
No, but I'm saying it could happen because it says it on their website. Okay, this one, yep, if you can try this. You have this? No. finished or confused? It can be 0, that's fine. What does that mean actually if it is 0? Which means what exactly? It's, the point is on the line then. Yeah. And this is another way to actually check if the point is on the line. Now of course it's not an easy way to check, but it is a way to check if the point is on the line. There should be no distance between the point and the line. Yeah, does that make sense? We'll see now if it's 0 or not. I think it might be 0 though. Such confidence. Right, okay, let's have a look. Now, what is the complicating factor here? What is making this different to the last one? Yeah. We have to, it's the y. We have to rearrange this. So I'll say 5y equals 2x plus 8. 2x minus 5y plus 8 equals 0. Yeah. Now you don't, wait, you don't have to do it exactly like that. If you rearrange it another way, that's fine. But we do need it in the form of ax, by, and c. So this is a, this is b, and this is c. Now you might think, well, what if I moved everything to the right? Then all the signs would be different. But you'd still get the same answer in the end. So the formula is a, which is 2, x plus b, y plus c, all over square root 4 plus 25, which is 0 over square root 29, isn't it? Which is, of course, 0. So in this example, the point is on the line, there's no distance between the point and the line. Okay, so write this one down. So far we've seen two formulas, the distance between 2 points and the distance between a point and a line. Why does it not make sense to have a formula for the distance between 2 lines? Why is that kind of a silly thing to think about? Yeah, it changes, doesn't it? Like, and in fact, most of the time the distance will be 0 if they meet anyways. So we don't really have things about distance between 2 lines. So we have distance between point and point, point and line, but not line and line. Okay. Is that okay? Yeah.
Secondary?
Yeah, if you have 2 lines, then there's not really a clear distance between them because it changes. Yeah.
That is
When
funny.
you have the distance between a point and a line, is it always at 90 degrees?
Yeah, this formula is always giving us the distance if you draw the distance at 90 degrees. Yeah. So it's, yeah, giving us the perpendicular distance. Yeah. Okay. Can I give you another one to try? Yes, can I scroll down? Right. So I don't know. Let's say this line is y equals 2x plus 3, for example, something like that. And let's say that this point here is the point 1, 6, something like that. And I would like okay, let me try this here. Yes, I would like this distance. Okay, anyone get an answer yet? Okay. No answers yet? Yes? Got an answer?
Okay.
Well, did you get an answer?
Oh, I know it.
Yeah. Is the answer right?
How can I know?
You can always tell if it's right. Yes. Okay, let's have a look at this. So this one's interesting because you're going to have to do this in a couple of parts, you know. I didn't ask for this distance because if I ask for this distance, that's easy. That's just the perpendicular distance. I didn't ask for that. And I didn't ask for this distance. This is the distance between a point and this point here. I'm looking for this one here. But in fact, this one should be done as first you should find this distance. Then you should find this distance. If you have these two, you can find this one here. So the first one, well, that's not so bad. Let's have a look at that. That's 2x minus y plus 3 equals 0. So that distance would be square root 4 plus 1. And then on the top it's 2x1 minus 6 plus 3, is it? So what's that now? That's 2 minus 1?
Yeah.
But then, huh? 1 over root 5.
Yeah. Minus 1 over root 5.
And then make it positive 1 over root 5 then. Yeah. Okay, so we have this, so that's good. Now, how about getting this distance? Nope.
Geometry, right? We use geometry.
I wouldn't even say it's as much as that. What's this point? No, what's this point here? 1. And this point here? No, because up here is 6. No.
How can we know?
This is a very rough sketch, so we can't tell.
What's this point here? What is it?
3.
No.
2 over
5.
Yeah.
Because if x is
Yeah,
1,
that's 3.
y on the line is 5.
Yeah.
So if this is 5 and this is 6, how big is this side? 1.
1.
But this is 5,
Yeah.
and this is 6, and this is a straight line.
I want to fix it. It will be same.
What?
I don't know.
This is 6, yes? Yes. So here is 6. So here to here is 5. Here to here is 6. So this distance is 1. Yes. So this is 1 here. Yeah?
Just 1.
Just 1, not 2. Just 1. Yeah. Okay. Right. So I can use. How can I find the x now? Pythagoras theorem, which I know we haven't done yet, but I mean you learned this in middle school. You have x squared plus d squared equals 1 squared. This squared plus this squared equals this squared. Now what? You,
We didn't take it as square. We took it as square.
yeah. A, B, C.
Yeah.
Yeah, okay.
So
Hang on. Wait, listen. Pythagoras should not be causing so many questions. You remember Pythagoras from middle school. ABC, a squared plus b squared equals c squared, whatever. So here, x squared plus d squared equals 1 squared. So then x squared plus 1 over 5 equals 1. So then x squared equals 4 over 5. So we finish off with x equals 2 over root 5. Okay. Now, I know we haven't talked about this in class yet, and we'll do that later, but really, we should remember that from middle school. It's like one of the basic math formulas from middle school that you should remember. Yes? You forgot it?
No, I didn't forget this. I meant like, I forgot why we got 5 in the first place.
Ah, yeah, we put 1 into this to give us 5.
This 1?
Yeah, because it's 1 here on the x-axis.
Got it, okay.
Yeah. Question? No? Is there a question with this? No.
Usually they add the fraction.
Ah, yeah, that's fine, yeah.
These squared but equals, yeah, that makes sense.
It's okay? Right, we'll go on to the next formula then. So there's one more formula to have a look at, if I can scroll down. So the last formula, we'll do 2 examples, is when you have a triangle, and one of the points is at the origin, 0, 0, and one goes up to here, x1, y1, and then we'll put another point like here, x2, y2, and we want to calculate the area of this triangle. Okay, so area is, the formula is, and maybe someone remembers this one if they've done it before.
Area equals
1 over 2. It started so well. What's next?
You can write, you know.
Oh, I know what's next. Do you know what's next? Yeah? A plus b? Oh, no. 0? No 0.
X1.
x1.
Minus X2.
No, quite clearly.
Y1. Y3.
Try again. Y.
Y1.
Y2. Minus x2, y1. Yes. Yeah. Y3 now. That's a new one. Okay, so this is the formula for area. But please remember, one of the vertices of the triangle must be at the origin. And in fact, we will do one with x3, y3 in a moment, but not yet, okay? You're too advanced for the class, okay? Just slow down a little bit. I know, just try and slow down a little bit, okay? So write this one down, and then I'll give you 2 points, and you can try and calculate the area. Okay. So we'll say, for example, that this point is 5, 6, and this point is 13, 14. So if you can try and calculate the area, please, of this triangle. You have an answer, yeah? So it will be a half, and again it doesn't matter which one you call x1 and y1, so it'll be a half, 13 times 6 minus 5 times y1, which is 14, yeah? So that would be a half, 65 minus 70. Is that right? 70, that's 65, isn't it? No, it's not, sorry. 78 minus 70. So that's a half of 8, which is then 4 then. Okay. So again, that's straightforward enough. The next one now with 3 points, yes.
I just want to know the
Yes, no, I know, yeah. I know, it's all good. Okay, can I scroll down? This is just area of a triangle, but it's a very special case when one of the points is at the origin then. Yeah.
Yeah, so there's other cases.
Yes. Can I scroll down now? Yeah. Okay, so if you have 3 points, so we'll say, for example, x3, y3, and then we'll say here x2, y2, and then here we'll have x1, y1. And we want the area of this triangle. Yes. Yeah. No, actually, because there isn't a formula. It's more of a process. I'll show you now. So I'll give you an example with some numbers. So, for example, let's say, I don't know, this one could be, I'll just make up some numbers like 2, and then this one here could be like, I don't know, 4, 3, and then this one here could be like 3, 5 or something like this. So, it doesn't really matter. The problem is the formula we have previously only works if we have 2 points and the third point is at the origin. But we can use that formula if we make one small change to this problem. I wonder if anybody knows. So what could I do so that I can use the formula in the last example?
Put 1 point in the origin.
Yeah, and how do we do that though? Because of course if we moved this point and made it the origin, then you can see our answer would be too big. Yeah.
minus
You're getting closer. You're getting closer. Yeah.
1 point that side. X1.
Yeah, that's it. So the verb I was looking for is translation or movement. So yes, you have the idea of the -2. What you do is you take the triangle and slide it down to the origin so it sits here instead. So what happens is you choose one of the points to take to the origin. So we'll say we'll take this one to the origin. And you would do that by doing a -2 and -2. It would make it become 0, 0. So as long as you do this on all of them, they'll all move together. So this point now becomes 2 and 1, and then this point up here would become 1 and 3. So the triangle, we slide it 2 units towards the origin. And now we just use the formula again on which point? This one? 1, 3 and 2, 1. Okay, so let's calculate that. Area will be a half x1, y2 minus x2. Sorry, I messed that up. This is x1, y1. This is x2, y2. So what's it? x1, y2 minus x2, y1. I think I have it. That's 2.5 in total, is it?
2.5.
Well, 2.5. Okay. 2.5. Yep. Okay. Now, if we look back at the example with the perpendicular distance, we found one application was we can use that formula to check if a point is on a line. If the point is on the line, then the distance is 0. So, is there any applications that you can think of for the area of a triangle? Yeah, go on. Oh no, not as fancy as that. Keep it simple. No. No. So, like for example, sometimes in maths, one question you might get is, well, do you know the word collinear? You all know linear. Linear means straight line. And what's the prefix co? Co, what does that mean? Like together, both, yeah. So what do you think collinear might mean? Maybe, yeah. Oh, sorry, I should say collinear points. What could those be? Collinear points. Yeah, collinear points would be points that are on the same line. So these points are collinear, but these points are not collinear. So here I can make a line between the 3 points, or whatever, 4 or 5 points, whereas these points, they're not collinear. I can't make a line that goes straight through them. So now that I've told you this, how could you check if, for example, 3 points were collinear? So if I have 3 points, and I want to check if they're collinear, or maybe they're not collinear, like this one, how can I check if they are or not? Yes? Now, yes, one way you could check is with the gradient, but, for example, imagine I have these 4 points. The gradient here and here would be the same, but I don't necessarily know that they line up. So I'd have to do something else as well. But you're right, we could look at the gradient. No. So, the way you could check 3 points are collinear is if you calculate the area of the triangle here, it won't be 0. But if you try to make a triangle here and calculate the area, it will be 0. Because it's like a flat triangle. Yes. Yeah? So you can actually use this as a way to check if points are collinear. If the area is not 0, then they make a triangle, so they're definitely not collinear. But if it is 0, then they all line up and your triangle is flat, and so it's collinear. Okay? So this, remember at the start of the class I was saying, although there's no, this is not on the syllabus, the formulas that you learn in this class, they could be useful for other types of problems. So in the exam, if they said check if these points were collinear, what you would have to do is work out the equation of the line and then check that the 3 points are on the line. Okay? Which is longer than just using the formula for area. So this is what I mean. You get some useful tools out of these 2 formulas. Okay? So I just want you to do one of each question because I just want you to practice using the formula. So just do B in each question. B. And you can start them now. There's a few minutes left. In fact, there's only there's 5 questions and 5 minutes left. So really, you should get them finished in the next 5 minutes. And then what? Gradient means slope. Yeah. Okay.
Will you do this in the homework?
Say again?
This in the homework?
No. I'm just trying to, for exam purposes, give you examples of the applications of the formula.
So that's basically find the area.
Yeah, that's
it.
it.
In the middle, we can move it, right?
Yeah, and that's it. If you needed to move it, you could move it as well.